The inlet section of a vacuum cleaner is 1 inch by 5 inches. The blower is able to provide suction at 25 cubic feet per minute. What is the average velocity at the inlet in meters per second? And if conditions are at sea level standard, what is the mass flow rate of air in kilograms per second? So let's take a look at this. So what we have is we have an area. I'm just going to put that up here. Slide's going forward on me. So my area is 1 inch by 5 inches, which is 5 square inches. And I'm able to provide suction at 25 cubic feet per minute. That is a volume per time, so that's going to be Q. That's my volumetric flow rate, 25 cubic feet per minute. So we need to calculate out the average velocity. How do we calculate out the average velocity? Q is equal to V times A, which tells us that V is going to be Q divided by A. So we start with Q. It's our 25 cubic feet per minute. There's a couple of problems with that. That's not in standard units. And so let's change that to per second, which is our more typical unit. So 1 minute divided by 60 seconds. That'll give us cubic feet per second, which is a more typical unit. And since we want to get to velocity, we'll be able to get to feet per second. So now we have our area, which is 5 inches squared. We need to convert that one to feet, so 1 foot divided by 12 inches squared. And then when we multiply all this stuff together, what we'll get is our average velocity is 12 feet per second. Although, that's not the answer because the problem's asking for in meters per second. So what do? We go and we look up the conversion factor in our equation manual or our textbook, and we can find out that there are 0.3048 meters in every foot. So when we do that calculation through, we're going to end up with feet will cancel, we'll be left with meters per second. So that gives us an average velocity of 3.66 meters per second. The second part of our answer is, okay, what is the flow rate in kilograms per second at sea level standard? So we look up what the density of air is at sea level, and we'll get 1.2255 kilograms per cubic meter. And so at this point, we're looking for mass flow rate. We know our mass flux is rho VA. And so now we have density. We know what the velocity is. We know what the area is. So if we go and calculate that out, we've got 1.2255 kilograms per cubic meter. We have a velocity, which we just calculated is 3.66 meters per second. And then we have 5 inches squared. So taking a look at this, we do have a problem because that's in inches squared. So what do? We need to convert that over to meters. So I'm going to take that entire thing, and I'll put it on the next line here. So we have inches. I know that there are 25.4 millimeters in 1 inch. I'm going to have to square that to get square inches, but that gives me square millimeters, so I need to convert that over, and so I know 1 meter is 1,000 millimeters. I square that too. Now we take a look and see what happens. Well, the inches squared here and the inches squared there will cancel out. Meter squared will cancel. Millimeter squared will cancel out. Millimeters squared. And then here we have meters squared. We have a meter here. There's cubic meters. That's going to leave us with kilograms per second. And so now if I go and I bash all those numbers into my calculator, I'm going to get a mass flow rate of 0.0145 kilograms per second.